Hi, good morning, everyone. Do you guys can hear me?
Yes,
Yes, Parveen.
Yeah, okay, thank you. So let me share my screen. So any questions related to the previous session? Anybody have any questions about retransmissions and to find dupacks? Anything related to the previous session, what we discussed? No questions? Okay. I can't see my screen. So today we will see what is TCP delays. We'll do the capture and also we'll try to do a lab for it. And we will discuss about what is explicit congestion notification, how it works, and same thing we will be doing a lab for it. So to start with, let me fire up the Wireshark. Just give me 1 minute. I'll open the pcap file. Is it something I saved as? Hmm. Once Wireshark. 1 second. I think it should be in my downloads. Okay, let me open my lab. I think I have it in my lab there. What is that? Some so it's loading. I'll show you the pcap files and I'll tell you how to set up this, lab, particularly for ECN. Not working. Should be just 1, 2, 3. I think we have to wait for some time. Okay, let's fine. I mean, let's go to the whiteboard until it boots up. And what about the documents and the device topic has been updated in the portal, and I think you guys should see all this study materials and documents uploaded there, right? You guys got the documents in the portal as well as the device topic. Can someone say yes, no, or any challenges? Any still you guys have problem with the study materials and device topic? I gave an unmute permission for everyone.
Praveen, I could see device videos, but
Hmm.
material I don't see. I mean, uh,
1 second. I think. Hmm. I think this is old. 26. 36 videos is old. Hmm. Is it? Mobile app. So, do you guys tried here? Any documents here?
Yes, we could not find any document. Only videos are there.
Okay, I think probably by today they will finish it. Yeah. Yeah, let's check tomorrow. You should see that soon. Okay, that's fine. So the whiteboard. So we all know this. I mean, this is a source and this is the destination. So this is peer-to-peer communication, right? So this is peer-to-peer communication, TCP. We know very well that what is three-way handshake. So if there is any problems, right? If a source and destination is talking to each other, and if there is a packet drop, so what happens here when there is a packet drop? What is expected? So do you guys know duplicate acknowledgements if there is a packet drops? So this guy is going to send a duplicate acknowledgement back, right? This is two packs. Because why? We know that how the sequence number and acknowledgement number works. Yeah. And this is an acknowledgement numbers. It should come back from the destination. And if your sequence number is keep increasing, like 1, 2, 3, for an example, I'm telling 4, 5, 6, 7. And if I send some packets and if it is not acknowledging it, so I am sending the sequence number 6. And this guy is not responding. Instead, he is doing a do pack for 5. So this happens when there is a packet loss, right? When there is a packet loss, let me write this clearly. When there is a packet loss, you should see the do packs coming back. So we know this. So instead, the Wireshark is using something like ECN. Sorry, yeah, not Wireshark. I am telling how the ECN works. Explicit congestion notification. So it should be agreed on both sides. So from the client as well as the server. So when they are doing a three-way handshake, they should agree upon this ECN. So explicit congestion notification. Why? So if there is a packet drops, there will be a do packs. So instead, the TCP congestion control, it works intelligently. It comes to know that, okay, there is a congestion in the network. So how do I know that there is a congestion in the network? So even in your layer 3 and layer 4, it has a cross marriage between this layer 3 and layer 4, where you come to know that there is a congestion. So instead of dropping the packets, the router is going to send a congestion notification back to the source. So what we know that how this congestion control works. So the window size squeezes, and instead of a packet drop, using the ECN, there will be no packet drops. It's a mutual understanding between the source and destination to keep sending and receiving the packet seamlessly. That's the whole point. So we know how this congestion control works. In the last class, we discussed about that. So this is source and this is the destination. So this is window size. So during the three-way handshake, both should agree upon this. Either the source can accept ECN, but we should get an acknowledgement from the server that it is also going to support the ECN packets. So if it happens, instead of a packet drop, both slows down this connection. The TCP actually does that. So when there is a slowness, then the TCP stacks will come to know that because it is using ECN. But instead of dropping the packets, it's going to reduce the window size This is generally TCP congestion control. So instead of dropping the packets, it's going to advertise its windows, and it's mutually and now it's a mutual understanding seamlessly happening between the source and destination to control the traffic without dropping the packets. So that's the whole point of ECN. So let's see the ECN capture now. Let me do a Wireshark for it. So there are key things. Either your TCP stack should be enabled with ECN. So to do that, I'll tell you how to check. If you are doing this lab, how to do that, and also how the ECN works. We're going to see that soon. Where is my... Yeah. So open the PowerShell for it. I think we can go to the lab and do that. And run the PowerShell in admin mode. I mean, you should have the privilege to enable this. Go to properties, font, increase. So I'm going to give a command netstat, netsh, int tcp global. So it this shows this my TCP stack. So here you can see this ECN capability is disabled. So I'm going to the command. So you're going to set your TCP global. And I'm going to enable this ECN capabilities in my TCP stack. So that is ECN, all lowercase. Is equal to enabled. So it said, okay, so now I'm going to check nets sh int TCP show global stack. So if you see this, my ECN is enabled now. So for that, let me open the Wireshark here. The capture is running. I'm going back to Chrome. And if I go to google.com, I'm trying to search for something. Wireshark. Stop this. Give a command DNS contains in the filter inside the colon. Wireshark. Again, go here, do a capture. So Now if I close this, restart this capture again, do we see packets? DNS contains why I can't see this. Is it the old Wireshark? So I want to see some TCP traffic. Why it's not happening? So TCP, stop this. Go to this capture, conversation filter, TCP, SYN/ACK. Let's make it bigger. So in the three-way handshake, if you see this, so my connection started here. You can see the SYN/ACK. Let me take the pen. So you can see this SYN/ACK, right? The three packets here, SYN/ACK. So inside this, if I go and expand this, so if I open up the flag, so we are proposing this. So we support ECN, we support congestion window. This two additional flags has been set because I enable the ECN here. So ECN capability is enabled. So once I get an acknowledgement from the server, so the server is acknowledging it. If there is a congestion, I'll definitely send the ECN packets. But for now, the conversation is going very well. There is a smooth conversation happening between these two. So I don't see any ECN packets going back and forth. So I'm repeating again. So when I'm proposing it, when I'm doing a three-way handshake, usually we send a SYN. That's the only flag has been set. But if a TCP stack, it supports the ECN, so you're going to set the ECN flag and also the congestion window flag along with your SYN packets. So you should see three flags here: SYN, then congestion window reduced, and explicit congestion notification, ECN. So this is ECN echo. So it is the server is echoing for my ECE. So I'm telling that I support explicit congestion notification packets. I do that, and I receive a ECN echo back from the server. That's the meaning of this, right? So only if both the TCP stack supports this TCP congestion control is going to work with ECN, right? So let's take one more sample capture. I think downloaded here somewhere. So you can see this SYN. Congestion window, ECN, along with SYN. So what is the reply back I got it from the server? So here this server is different, right? It is different. Here it is different. So it is sending an acknowledgement not only with ECN echo. I think yeah, it is doing also an ECN echo here. This is from the server 1.1.12.1. So this is your client and this is your server. This is your client and this is your server. So this is the request coming back from the server to the client. And it is telling that it's going to support the ECN. But in the normal conversation, at times 90% you won't see this. But if both the TCP stacks supports, then you should see that. And you can see this here, it's a congestion happening here. This is a sample capture where the congestion happening. So it sends an TCP window update. So we know that, right? So if the TCP window update has been sent, that it cannot scale up further. So there is a congestion in the network. So if I open this particular packet here, the TCP window update, the scaling factor is reducing. You can see this scaling factor is reduced to -2. So we know that the window size is started shrinking now at this point. So if you come down, you can see a lot of TCP window updates. You can see this. We said the source is 1.1.23.3. It's your client. So you can see the scaling factor has been reduced because the congestion window is reduced. And you can see the echo back coming from the client. It's acknowledging it. So who is sending this? This is the server sending this back. There is a congestion. So this Windows updates that's works together with this congestion window, and we'll come to know where the problem is. So you can see this for everything there is an update coming back. And if you scroll down all the way down, you can see this congestion window is keep reducing. It's keep on the server is sending this back. Go to export info. You see a lot of Windows updates here. If I click on anything, apply as a filter is selected, close this. So who is keep sending this TCP Windows update here? 1.1.23.3. So if I go to this particular conversation, if I go to conversation filter and TCP, I can exactly find the stream. So it is a GET request going out from 1.1.23.3, the source. This is the destination. So this is again a GET request from the client. If If you scroll down all the way back, so there is a fin packet here. So once I got who is sending this 200 OK, this is the server. Say 200 OK is sent by the server here to him. So this guy is keep reducing its window. So ECN works with layer 2, sorry, with layer 3 and layer 4. They're talking to each other, and this actually basically they're controlling the traffic. I mean, TCP is doing it, but who is sending the notification is in the layer 3. If I go to any ECN packets here, so you can see this ECN CE. If you see a normal capture, you don't see this explicit congestion notification. This is sent by the layer 3 device. It's telling that there is a congestion happening, so we have to slow down on both ends. So this is how the congestion control works. So let's try with iPerf. If I disable this, before that, let me disable this. ECN capability equal to disabled. Now let's do a capture again. Now I'm going to any website. I do a TCP. Go to any conversation here, Wireshark. Conversation filter TCP. So do you see any ECN packets now? This is the conversation what we did for the Wireshark. So I opened the sample captures in the Wireshark website. But here now, I'm not sending anything with ECN packets here. I have to do it from TCP dot analysis dot flags equal 1. Flags dot sin equal 1. I go here, conversation filter TCP. Why there is a breaking? I mean, I can't see that. flags.send equal 1. If you see this, there is no ECN packet sent between source and destination. Right, this is my source. So check my IP address here. .122.160.50.111. I don't see this anything ECN packets coming back because I disabled this in my TCP stack. So any questions related to ECN? We'll see that one more capture. There we will see this ECN packets.
So, Parveen,
Yeah. Yeah, somebody is talking.
hi, Parveen.
Yeah.
This is Amarjit. So,
Yes, Amarjit.
is it right to say that the ECN is the way to avoid the packet get dropped?
What is that? Can you repeat your question?
I mean that like is this the ECN when we enable the ECN that right? So
Mm-hmm.
we can see in the Wireshark that is that and when the devices start getting know that like they see the ECN packet that right, and then they slow down the traffic that right. So does that mean that it will it's the way to avoid the dropping the packet?
Yeah. Yeah, instead of so when the retransmission happens, when this window scaling factor comes in, then this all happens after the packet drops because if the server is busy, if it is not receiving a good amount of traffic, good amount of requests, so there will be a congestion, right? There will be packet drops. You will see a lot of duplicate acknowledgements. But instead, if there is instead of dropping the packets, is going to send this. There is an explicit congestion happening. So like, we want to slow down the connection. So it's just the layer 3 is helping the layer 4 to control the traffic flow between source and destination in a
To
more consistent and seamless way of sending and receiving traffic.
so basically it's avoid the dropping the traffic that
Yeah,
right.
correct.
And like mm, another question I was so who at what like it's a let's say one thing like we need to enable the ECN on each device there right, if we want to use this feature
Yeah,
that right.
yeah.
And let's say in over I mean that how at what sorry I forget skip from my mind. I will ask later that question.
Yeah, it
I
should be
forgot that
enabled
was
on
yeah.
both and I mean it is if both stations are going to support this, only then it's going to work.
So the ECN, let's say we have the like within the sender and the receiver that right. We have the like four network devices, four router that right.
Mm-hmm.
And do we need to enable the ECN on each router, or we can enable on the one? Like how it works that like where we need to.
No, TCP is a peer-to-peer, so there's nothing you're going to do with a router. Router is once you enable this ECN, the router is going to send this CE packets in the layer 3.
Okay.
Yeah, because router is a layer 3 device. So whenever there is a congestion and in the layer 3, you can see that. I mean, still I think I am sharing my screen, right?
Yes. Yeah.
So in the layer 3, all you see is this ECN here. If it is CE, here there is no ECN packet, right? Because we are not used the TCP stacks here for this particular capture. It is not, we didn't enable the ECN. We disabled this. But if you go to the sample capture, I think I should enable this downloads here. If I go to anything here, open up this. Where is CCN? See acknowledgement coming back from 23.1. I want from 2012.1. So you can see this, the values changed to ECT0. So it's coming back
Yeah.
from the server, right? 1.1.12.1. So this is explicit congestion notification has been sent between the layer 3 devices.
Yes.
That's it. But this congestion control is managed and controlled by TCP stack.
Okay. Okay.
Because
Thanks.
Windows updates and everything is managed by TCP stack. It can
Yes,
send just a notification if there is a congestion.
Yeah. Thanks, Ravi.
Yeah, no problem. So, okay, so let's continue then if there is no questions.
Praveen, a few questions.
Yeah. Yeah,
So
Balachandra.
one minute. So the duplicate acknowledgements we will not be seeing when we have the ECN capability enabled in the Wireshark when we do that.
We
Is that
can't say that 100%. We can't see the duplicate acknowledgements because if that particular stream of traffic, if you have an ECN, yeah, definitely you should not see duplicate acknowledgements. But the few duplicate acknowledgements are fine. But in the previous class, if you remember, we have seen a lot of duplicate acknowledgements. It should not happen like that. Substantial amount of duplicate acknowledgements. Few are fine. Sometimes it happens, right? In the few duplicate acknowledgement is fine.
okay?
So that depends on your whole capture and what is the amount of duplicate acknowledgement you would see there.
Okay. So now the advantage when we enable this ECN is like the traffic will not be dropped even if there is a congestion, right? That's my understanding.
Yeah. That's a proactive measure where then when it's facing when you started experiencing the congestion, it's going to send the ECN packets, explicit congestion notification, so that the both stations should be aware that there is a congestion happening, so I have to slow down my connection.
Okay.
I mean, that's a pretty faster way of doing instead of dropping the packets and doing the congestion control. This is a proactive measure. Instead of dropping the packets, we are going to start doing the TCP get to know that, okay, I have to start my congestion mechanism here because there is a congestion happening now.
Okay. So is it recommended like ECN is recommended to enable it in the end devices between source and destination so that it's advantage, right? So by default, I see in the TCP stack it is disabled. So is it recommended to get it enabled, or how we see that like? Or is there a drawback when we enable this ECN or any other drawbacks?
I mean, there is no drawback in doing it, but it is disabled by default is something I will research and come back. But I don't see any drawbacks here. Maybe in the production by design, I have to do a little more research and I'll come back to you in the next class, but maybe tomorrow.
Okay. Now, like consider like if you have around 10 devices, and if congestion happens in the middle between any two routers, the end devices are knows it and does that ECN. If it is ECN is enabled, it does that.
Yeah,
Right?
yeah.
Is there a way where we can identify like which two devices are between which two routers the congestion actually happened, so we can look at it. Is there a way like?
That is actually a good question. But I would say I will ask you one more question. So from that you will get your answer. So what is the difference between the TCP delay and network delay? How do you find that in Wireshark?
No, I'm not sure. TCP delay.
We discussed that.
So
We discussed as in the previous class. So if there is any congestion, if there is anything problem, latency is happening at the layer 3, how do you find using a Wireshark? And how do you know that it's a problem with the layer 3 or it's a problem with the layer 4, where the latency is happening?
I'm sorry, I'm not able to recollect.
Okay, no problem. So we have now, I'm going to do one more lab here.
Okay.
Then you will know that where the problem is. Is it happening exactly on TCP or layer 3?
Okay.
So that's
And
why people stumble upon, right? Because sometimes they think it's a TCP or it's a layer 3. What is that? Who is causing it?
okay, one more question. When you open that sample Wireshark, uh, there was a congestion window reduced. It is also set to 1 when there was a sync packet. For a SYNAC, the congestion window reduced was set to 0. It was saying not set congestion. So is there a difference, like when the reply is coming from the server, the ECN is set to 1, but the congestion window reduced is 0. What does that mean, or how do we see that, or how
Where is that sample capture you're talking about here?
the one you have opened it,
Yeah, this is the
saved
TCP
one.
in sample.
Okay. In the stream, SYNAC and ACK, that any one. Yeah. Okay. If you go to the SYNAC, if you click on
Okay.
the SYNAC.
So you mean to say here, I don't see this CWR, congestion window reduced flag.
Yeah, congestion window reduced was showing 0. I mean, so it was not set, I believe. So, is there a when the client is saying congestion ECN is set and congestion window is also set to 1, and reply is coming with congestion window reduced is not set, is there a difference, or how do we see that, or
1 minute, let me go through this capture here.
okay.
This is so sending this. Mm, so sending this congestion window reduced this 12.1. So you see this congestion window reduced set here, right? From the destination 1.1.12.1.
Okay. So it
So
was,
yeah,
that was a
in the
different stream.
in the proposal, it is not happening. So
Okay.
when there is a congestion started, it's going to set this congestion window reduce flag. You can see that after this, the window scaling has been reduced to -2.
Okay.
So whenever it sees a congestion, it's going to send it.
Okay.
It is just a proposal happening in the beginning. But even if you see this explicit congestion notification, it's definitely going to support the whole TCP congestion control. So these are all the parameters
Okay.
inside this congestion window, right?
It's fine. Yeah. Clear. Thanks.
Yeah, no problem. Hi, Deep.
Yeah, hey.
Deep, do you guys use this congestion window enabled on your
No,
servers?
no.
Okay. Then I'll research on that. Why it is not enabled by default. Okay, so now okay, Deep, thanks then. Let me check on that. I thought you guys might be using something like this. So let's go to the one more capture here. I think it should be in my downloads. So now we are going to find the app delays. So Balachandar, sorry. What's your name?
Balachandar, Bala. Yeah.
Balachandar, right? Okay. So you asked a question that what if a router in the middle has a problem, right?
Yeah.
So you can take this example. I mean, this is for the whole, this is a separate topic we are discussing. This is about we are spotting the delays in the app application, TCP. So for that, when you get a capture something like this, if there is an application delay, this is all not very much needed here. You have to go to your TCP, go to the bottom. If you expand this timestamp, you can see time since previous frame in the TCP stream. So I'm going to remove this. So you have to go to your TCP header, expand this. You have an option like a timestamp, expand the timestamp. You should see time since previous frame in the TCP stream. So right click, apply as a column. Since it is very big, I'm going to edit this column. So I'm going to do this TCP delay. Right? And then I'm going to sort this TCP delay. So I'm coming back all the way back here. You can see this cursor. Let me open this pen. So you can see a cursor here. Click on it, go to the bottom of the page. So from here, I can see the longest delay in the TCP in this particular capture is this. It took about 19 seconds. This is the client sending a response after 20 seconds to the server. Right click, conversation filter, TCP. So why it happens here? Example, this is a sample capture I have taken where when I open a website and if I didn't punch my username or password there, I'm waiting for it. The server is waiting for it. So this is a delay caused by the client. So from here, I can't come to a conclusion that this is a problem with the client. Right? So here we see where is the actual overhead is. Where is the actual congestion happening here? So from all the way back from here to the bottom, from the beginning of the capture until until the whole conversation, if I have taken the whole conversation, so I'm coming to the end of my capture, right from the beginning to the end of my capture. And if I see this, the longest delay I can see from this whole TCP delay is this conversation. So I'm telling that, so from this point, I couldn't come to a conclusion that it's a problem with the client or server is causing this slowness for all the traffic. So here I see the highest TCP delay is happening for this particular conversation. So I'm going to click this because you can see this all 2 seconds, 3 seconds, 4 seconds, 6 seconds, and 9 seconds. So I'm going to click on this particular packet, 9 second, right click, conversation filter, then TCP. So from here, my whole conversation starts here. This is my stream index 7, only this particular conversation, not with any other server. Somebody asked me a question, so I send a SYN. So the SYNAC back I got within 1 second, 1 millisecond. So I don't see anything here apart from this final FIN packet. It took about 1 second for my client to respond back to the server. But if you see, the server took about 9 seconds to respond back for my request. I mean, this is application traffic that's going on. It took about 8 seconds to send it back. And you can compare the delta time here. Your delta time and your TCP delay, it's exactly matching it. So this is not a network round trip time, isn't it? So if you remember the previous classes, the network round trip time is purely based on SYN and SYNAC because you can see there is no traffic is being sent or received. It is just a three-way handshake. So application traffic started here. You can see your sequence number is keep increasing from 518.644.4037. So your sequence number is keep advancing here. So I'm sending you traffic, but the server took about 9 seconds to reply back. So this is a problem with the server here, not with the client. So irrespective of how many devices in the middle, it doesn't matter for me, right? So I can have n number of devices in the middle. So this is a whole conversation between two stations because this is a TCP. Right, this is R1, this is R7 example, this is a server and this is a client. So the three-way handshake is how it is happening. The three-way handshake is happening like this, isn't it? It's happening like this. And the server took about 9 seconds to reply back to my client. So it is something problem with the server. There is no problem with the middle devices. Whatever it is connected is fine because I see the network round trip time between the source and destination is fine here. I have concluded. So I don't want to check my layer 3 traffic. So I have to look only for my TCP. Are you guys are good and clear with this?
Sorry, Praveen, can you repeat one more time? Sorry for that. I had the issue with my headphone. Sorry, can you repeat that one more time?
Yeah. I mean, which particular part you missed out, Amarjit?
Like the how we identify that it's not the layer 3 or it's a layer 4 TCP issue that, right? You mentioned that the delay is happening on the TCP that, right? Not at the layer 3. That
Yeah.
part.
If you see this capture, so this is network round trip time. So I send a SYN, I receive a SYNAC back. So this whole conversation happened within 1 millisecond here between this client and server, right?
Yeah.
So how do I find that how many devices are connected in the middle? Amarjit.
Mm. Through the layer 3 that, right? It's a
Yeah.
from the layer 3 packet.
If I
that,
put
right?
it something here, phone conversation, so it's a 51. TTL is 51. So how many hops are there between source and destination?
Yeah, it's around 50, around 50
So it started with 64.
or 64. Okay.
So 13 hops. So my whole round trip time from source to destination, crossing all the layer 3 devices, it took just 1 millisecond for me. Because you can see this particular conversation, everything. If you're really sending some traffic, you can see there is an increase in your round trip time, isn't it?
Yes, yeah, that's yeah.
So here I don't see any spikes, right? I don't see any spikes here. So I have a separate filter like TCP delay. For the whole conversation, I don't see any delay. But this server took 9 seconds to respond back. If I go to view time format, and if I do a default time of the day, so here, if I go to the TCP delay, I'll get to know who is causing a problem here.
Yeah, it's a
Exactly.
network device, is that right?
So this server is responding after 9 seconds here.
Yeah.
So using this TCP delay, I come to know that there is a problem with layer 4, not with layer 3.
So basically, like we can like if there is a no difference between the time for TCP, that right? That's we think that there is no issue with that TCP and the TCP side, that right? TCP there, that it's a issue with the layer 4, that right?
I didn't get you, Amarjit. What is the
I mean,
question?
like if it's a there is a no much time difference between at the TCP layer, then we think that like it's not issue with the TCP, that right? Like I mean, the time is constant. Like no big difference between the time to send and receive the packets through the on the TCP layer, that right?
No, sorry, Amarjit. I didn't get your question. You can rephrase it bit
Okay. I mean, like
better.
you meant under the TCP delay, that right? You said that like you didn't see any delay between that because the time is not varies that much, that right? It's just slightly like it's like consistent, that right? Like just one.
No, in the whole stream, if you see the packets, here there is no congestion here, right? But suddenly it spiked to 9 seconds here.
Yes.
So that's my sweet spot. So from there, I'm going to figure out. So who is causing the delay? Right? So now you can go to the application team. You can tell that this is your server. I see the response like this. You have to check. Is it because of a lot of resources being consumed, or how your application works? That's something that's not our cup of tea, right? It's their duty to figure out why it is causing slowness. If you have an access, well and good, you can do more research. But this is just the direction where I have to go and approach where the problem is, right? That's our duty.
Mm-hmm.